So today I will take some more. So what is the Laplace transform of derivatives and the integrals? So here we have the concept called Laplace transform of derivative. So we know that I will just make you understand in terms of the theorem. The transform of the first and second derivative of f of t satisfies. So if we have f of t as a function, then if I find out f dash of t, I may find out f double dash of t, so on I may find out fn of t depending on the value of the function t. If that is the case, then how do you find out the Laplace transform of f dash of t? So please remember the formula. Laplace transform of f dash of t will be given as s into L of f of t minus f of 0, f at the point of 0, if it is f dash of t. Similarly, if it is L of f double dash of t, then this is s square L of f of t minus s into f of 0 minus f dash of 0. So this is our L of f double dash of t. So this is L of f dash of t and this is L of f double dash of t. Clearly, f of t is the continuous function for all t greater than or equal to 0 and it is satisfying the exponential order. Similarly, f dash of t is also piecewise continuous and it is also having the exponential order. Similarly, f double dash is also a piecewise continuous and it also satisfies the exponential order. Then and there only we can find out the Laplace transform. That's what this particular theorem talks about. So please remember, whenever you want to solve the problems based on the derivative, you should remember the formulas. So in general, for example, if I have the nth derivative, so fn of t, I want to find out. How do you do that? It is Sn of the nth derivative of L of f of t minus Sn minus 1 of f of 0 minus Sn minus 2 of f dash of 0 minus Sn minus 3 of f double dash of 0 and so on up to fn minus 1 of 0. So this is your final result. So if you want a 3, then you have to take if suppose it is f 3 times of 3, I mean you can, I want to say that third derivative, if you want to find out, put n equal to 3. If you want fourth derivative, put n equal to 4 and so on and so forth. So in general, remember for your syllabus we have f dash and f double dash, up to f double dash we have. So you can remember this formulas. So by using this particular formulas, we're going to find out the Laplace transform of the derivatives. Okay, so it's a very important concept and try to understand it now. Okay, so this is all about the theorem here. Now let's start with the examples. How do we use the examples in order to solve this Laplace transform of derivative? So here you can see, guys, using the Laplace transform of derivative, find the Laplace transform of the following function. Here f of t is equal to e to the power minus at. So before you ask me the question, I will just tell you, ma'am, when you can solve this particular example simple way, that is that we know that Laplace transform of e to the power minus at is 1 upon s plus a. Then why do we use this method? Because though we know that there are many methods, so this particular Laplace transform of derivative will help us to find out not only the easy derivatives but some difficult derivatives. By finding out this value, by this particular value will be used to solve some other difficult problems. So via derivative, by using the derivative method, I will show you those examples in the next you know I mean maybe in the next examples I will show you how we will be utilizing it. First we will use the simple examples to understand the technique how to solve the solve by this method. So f of t is e to the power minus at. Since it is a derivative method, I need f dash. So f dash of t will be equal to minus a e to the power minus at. Okay, so we know the formula, that is Laplace transform of f dash of t is equal to s into L of f of t minus f of 0. So you may ask me, ma'am, when to use the first derivative, when to go up to second derivative. Look at the given function f of t and try to see the derivative. There also you have tried to find out the same function. If you are getting the same function, it is easy to calculate. I'll show you how you use it. This is the L of f dash of t. F dash of t means minus a into e to the power minus at is equal to s of L of f of t, it is e to the power at minus f at the point of 0. So if I put t is equal to 0 here, this is e to the power 0, which is equal to 1. So here I'll write directly 1. Now clearly you can see this is of the form Laplace transform of k into f of t. So by using the linearity property, I can write this as k into L of f of t. So therefore it is minus a into L of e to the power minus at is equal to s into e to the power minus at here, minus 1. So here also L of e to the power minus at is there. Here also L of e to the power minus at is there. I will take this term on the right hand side and this minus on the left hand side. This is equal to 1 is equal to s plus a into Laplace transform of e to the power minus at. But I am interested in this Laplace transform. This implies Laplace transform of e to the power minus at is equal to 1 divided by s plus a. So you know by using the general method how to find out. By using the method of derivative also, we can find out the value of Laplace transform of e to the power minus at. So this is how we are supposed to find it out. Okay. Did you got the point, guys?
Yes, ma'am.
Okay. So now once you have solved this example, let me take the next example here where the Laplace transform of the function is given as cos at. So f of t is given as cos at. So if f of t is cos at, what is f dash of t then? So f dash of t is minus a sin at. So since you can see sin at I have got. So since the given function is cos at, so I'll differentiate this. F double dash of t will be minus a, I keep as it is, sin at into differentiation is a into cos at. So this is equal to what? It is minus a square cos at. So here I've got again the given function. So this cos at and cos at I've got here. Now apply the formula. Laplace transform of f double dash of t is equal to s square into L of f of t minus s into f of 0 minus f dash of 0. This is equal to L of f double dash of t means it is what? It is f double dash is minus a square into cos at here is equal to s square into what is L of f of t? L of f of t is cos at, that is L of cos at minus s into f of 0. So here your f of t is cos at, f of 0 wherever t is there, if I substitute 0 then it is 1 minus f dash of 0. F dash of 0 means it is minus a into sin 80. Wherever t is there, if I substitute 0, then sin 0 is 0. This value will be 0. So what you are left with? This here you can see this term is with respect to again k into some f of t. I can write this as minus a square into L of cos 80 and this is equal to s square into L of cos 80 minus s. So here this term also includes cos 80, this term also includes Laplace transform of cos 80. I take this on the right hand side and this s on the left hand side. So s is equal to s square plus a square into L of cos 80. But I am interested in this. Therefore, L of cos 80 is equal to s upon s square plus a square. Are you following, guys?
Yes, ma'am.
Okay, so like this, you're supposed to solve the problems on the derivative. Let me take the next example. Here f of t is sin square t. What is f dash of t? It is 2 sin t, sin derivative is cos t. So 2 sin a into cos a is sin 2a. So now what I want? It is Laplace transform of f dash of t I need. So Laplace transform of f dash of t will be equal to s into L of f of t minus f of 0. So what is f dash of t? F dash of t means sin 2t here. So Laplace transform of sin 2t is equal to s into L of sin square t because this is my f of t minus f at the point of 0. So f at the point of 0 is sin 0. Sin 0 is 0. So I will be getting here Laplace transform of sin 2t is equal to s into L of sin square t. So this is equal to s into L of sin square t. But I know what is sin 2t, the Laplace transform. It is 2 upon s square plus 4. So therefore, Laplace transform of sin square t is equal to 2 upon s into s square plus 4. This is the answer. Okay. So like this, you're supposed to apply the Laplace transform. Okay. So let us see the next example here. next example, f of t is equal to cos square t. F of t is equal to cos square t. Then you are taking the next differentiation, that is f dash of t will be 2 into cos t. Cos differentiation is minus sign, so therefore I have taken here minus sign. So it is minus 2 sin into cos, it is minus sin 2t. Now again apply the Laplace transform of f dash of t, that is s into L of f of t minus f of 0. This is equal to Laplace transform of minus sin 2t here, because what is my f dash of t? It is minus sin 2t, which is equal to s into L of cos square t. F of t is cos square t minus f at the point of 0. So here f of t is cos square t. F at the point of 0 means it is cos square 0. That is equal to 1 here. So again, I want this value. So take this one on the other hand. This is s into L of cos square t is equal to 1 minus 2 upon s square plus 4, which is equal to s square plus 4 minus 2 divided by s square plus 4. This is s square plus 2 upon s square plus 4. But I want Laplace transform cos square t. Take this s on the other hand. This will be the final answer. Okay. So when you are doing, please do with the correct derivatives. Whenever you're taking the derivative, don't miss the minus sign, plus sign, because if one plus sign, minus sign you miss, or if you make the derivative mistakes, then the whole answer will be wrong. Okay. So now let's understand this example, guys. I was telling, right? So we have to, we're specifically we're using this Laplace transform of derivative in solving the problems. I mean, by using, for example, I'm evaluating this derivative. By evaluating this particular Laplace transform, I'm finding out the value of these two. So this is how this derivative function play an important role. Let's understand this problem now. So here they ask us to, using the Laplace transform of, yeah, see where to take only the first derivative and where to take the only second derivative. It depends on your problem. I told you here, if you see this example, here, when I have told you first derivative, when you taken, you have got sin 80. When you take the second derivative, you got cos 80. So that means when you get some common stuff, it is easy to handle, because I can take at one side and I can solve it. So that time you try to take the depending on that consistency, you can go up to first and second derivative. But for your syllabus, only first and second derivatives are there, and not necessary to worry much, because there are only few examples. Whatever I'm solving and whatever examples are given, that you have to emphasize on. Only first and second derivative are available. So maximum we will be using the highest up to second derivative. Okay. So here also you can see just this is a sine function. Go up to, you will get a sine function. So here you can see f dash of t will be getting sine function. You can stop at this point. Here cos function is there. So here this particular function you can see cos square t. As you know, this sin 2t is very easy to handle by using the Laplace transform. So therefore no need of going further. So you can see Laplace transform of sin 2t is known to us. With the help of this, we can find out the Laplace transform of cos square t. In that way, you should make a, I know, make up your mind to solve the problem. Okay. So let's solve this example now. It is of the form t into sin 80. So we have to find out the Laplace transform of t into sin 80 by using the derivative method. Let me take f of t now. F of t is t into sin 80. Can someone tell me we can solve this same example with what method? It is of which form? Is it not in the form of t into f of t, guys? Yes. Yes, Shubha, you are correct. It is in the form of t into f of t, and you can use the formula and you can solve it. But when they're mentioning use the derivative only. So now f of t is equal to t into sin 80. So here f dash of t will be equal to, here it is, there are two terms, t as it is, differentiation of sine will be, it is a into cos 80 plus sin 80 as it is, differentiation of t is 1. So this is nothing but at cos 80 plus sin 80. So this is your first differentiation, f dash of t. Similarly, find out f double dash of t. F double dash of t will be equal to, here again there are two terms. A I take completely out. T as it is, differentiation of cos, it is minus a sin 80 plus cos 80 as it is, differentiation of t is 1. Okay. Then similarly, differentiation of sin 80, it is a into cos 80. Now take this a inside, This is minus a square t sine at plus a cos at plus a cos at. There are a cos at means it is 2a cos at equal to 2a cos at minus a square t sine at. So this is your f double dash of t. So I have found out here. So this you have got f double dash, you have got f dash. Now use the formula for Laplace transform. That is Laplace transform of f double dash of t will be equal to s square into L of f of t minus s into f of 0 minus f dash of 0. So apply the formula guys. So L of f double dash of t is what? It is Laplace transform of 2a cos at minus a square t sin at. Okay, this is our left hand side. It is equal to s square into L of f of t. It is t into sin a t minus what is f of 0? If I put 0 here, since t is there, sin 0 is 0. This term is 0. And what about f dash of 0? F dash of 0, you can see this term is containing t into cos, and this is sin 0. So t is 0 means this term is 0, this term is 0. The whole term will be 0. So what is the right hand side? Only s square L of t into sin a t. So this term we will get. Okay. So this, if you can see from here, what I'll do, this we can write it as 2a into Laplace transform of cos at minus a square into Laplace transform of t into sin at is equal to, on the right hand side again, s square into Laplace transform of sin at is there. So this is sin at term, this is sin at term, t into sin at term. Take on the other hand. So it is 2a into Laplace transform of cos at is equal to s square plus a square into Laplace transform of t into sin at. Okay, so I am interested in this Laplace transform. So, but I know already what is cos at Laplace transform is. It is 2a upon s square plus a square into Laplace transform of cos at. So, what is Laplace transform of cos at? It is s upon s square plus a square. So, the whole answer will be 2as upon s square plus a square the whole square. So, this is the Laplace transform of t into sin at. So, I have got the Laplace transform of t into sin at. Let me take this as equation 1 now. But what they ask us to find out? They ask us to find out Laplace transform of 2 cos at minus at into sin at. So that is nothing but here you can see 2 sorry 2 into cos at, 2 into cos at, this one you can see from these two, from this f double dash you can take, if you take a out, this will be 2 cos at minus at sin at. This is what they ask us to find out. Okay, so that is a into f double dash of t. That is the meaning. So now let me find it out that. So a, if I take out from this equation, I am taking a out. If I take a out, it is Laplace transform for 2 cos at minus at into sin at. That is equal to, you can see this is equal to what? S square into L of t into sin at. That is equal to s square into L of t into sin at. But I already found out Laplace transform of t into sin at by using the equation number 1. I write the answer for it. That is s square into 2as upon s square plus a square the whole square. So this is equal to s square. This a I am taking on the right here right side. That is s square upon a into 2as upon s square plus a square the whole square. This a cancels. So what is the final answer? It is 2s cube upon s square plus a square the whole square. So this is how we are supposed to find out the answer. What I am doing? I am finding out the value of this by using the calculated derivative, or calculated Laplace transform by using the derivative. Similarly, they ask you to find out the next one. You can see it is sin 80 plus 80 cos 80. It is sin 80 plus 80 cos 80 is L of f dash of t. L of f dash of t formula you use. L of f dash of t is what? It is s into L of f of t minus f of 0. So s into L of f of t means what? It is t into sin 80. Here I have written f at the point of 0 is 0. So therefore s into, what is L of t into sin 80? It is 2as upon s square plus a square the whole square, which I have already calculated from equation 1. Substitute, we will be getting the answer as 2as square upon s square plus a square the whole square. So in this particular example guys, it is very clear that we are using this derivative method to solve the Laplace transform of one function. In turn, by using the Laplace transform of this, we will find out the Laplace transform of different functions. Okay, so like this you have to utilize it. So one example I've solved, one example I've given you guys. You try this. Laplace transform of t into cos hyperbolic t you find out, and then you apply the same values for finding out the Laplace transform of the other two. Okay, so this much you do it. In the next class I will continue with the Laplace transform of the integrals. Okay, so just if you have any doubts, any questions, now you can